Okay, so we're going to work through some mole ratio problems here and give you some examples of what we call mole to mole problems. So again, these are going from mole to moles. And the key is that we're going from one compound to another compound. And so in order to do what I call the switch from one compound to the other, we're going to need our mole ratio. Okay, our mole ratio. So let's just look at what we have here. First off, you're given the formula already, and you can tell that it is balanced. So that's our first step. Now, then the next thing is it says how many moles of aluminum are needed to produce this many moles of aluminum chloride. So again, the first thing that I'm going to do is I'm going to write down what the problem says. It says that I am needing to produce, or I am given 3.33 moles of aluminum chloride. Okay, that's what they're giving me. I need to produce that. And so what they're asking is how many moles of aluminum do I need to produce this many moles of aluminum chloride? So the mole ratio that I am going to be looking at here will be the moles of aluminum and the moles of aluminum chloride. Now, I'm not really paying attention to which order that I'm writing them. I'm just looking at what we need. So I'm going to get my numbers. So I would always go up here and either underline or highlight what we're talking about so that you don't get them confused. So in this case, I have 2 moles of aluminum for every 2 moles of aluminum chloride. Now, this works out pretty nice because it's going to be a 1-to-1 ratio. And if it is a 1-to-1 ratio, then we're going to know that the number of moles of aluminum chloride that I need to produce are going to be exactly the same as the moles of aluminum chloride that I need. And so I already know my answer. Okay? So that is because it's a 1-to-1. Now, only because it's a 1-to-1. Now, let's talk about how we're going to show our work to verify this or to make sure that we're backing up our answer with some kind of work. So the first thing that we're going to do is we always write down what's given. Okay, so that's always going to be our first step. Okay, so I have moles of aluminum chloride. So that's always the first step, is to write down the given. Okay. The second step is then to do our mole ratio. So in this case, remember, if we have moles of aluminum chloride in the numerator, I need to put moles of aluminum chloride in the denominator. And I'm looking for, or where I'm going, is to moles of aluminum. So that has to go in the numerator. So what I'm given, moles of aluminum chloride, is going to go in the denominator. Where I'm headed to, or what I'm looking for, goes in the numerator. Now again, I need to put my coefficients out in front here. This is not going to be that big of a deal because we just said it was a 2-to-2 or a 1-to-1. I don't care if you put a 2-to-2 there or a 1-to-1. I'm going to go ahead and put 2-to-2 just because that is the numbers here. Okay? And again, we know that 2-to-2 is a 1-to-1. And so there's my supporting work to get my answer. Okay? So again, let me go back over this. Whatever you put in your numerator, whatever the given is, must go in your denominator on this side. And then that way, those will cancel out because moles of aluminum chloride divided by moles of aluminum chloride is just 1. So you can see the answer. Okay, so now let's do the next one. Again, I'm still using the same equation, but this time they want to know how many moles of hydrochloric acid. How many moles are needed to react with the 3.33 moles of aluminum. Okay, so I want to produce 3.33 moles of aluminum chloride, so I needed 3.33 moles of aluminum. So now the question is, how much hydrochloric acid do I need to mix with that aluminum? to get it. So again, I'm going to come over and I'm going to look at my mole ratio. So moles of aluminum, moles of HCl, and come up to my problem and look. So again, this time I am looking at aluminum. So this time I'm going to highlight it, and HCl. So I'm only looking at these two values. So if I put them where they need to go, I have 2 moles of aluminum for 6 moles of hydrochloric acid. Again, if you wanted to, you could reduce that down to a 1 to 3, but I typically go ahead and use exactly what's in my formula. So here we go. Again, we're going to write down the given. So I have 3.33 moles of aluminum. I have my mole ratio that I need. Now be sure you put it correctly. So just because I wrote it this way over here does not mean that that's what I need. So since I have moles of aluminum, I need my moles of aluminum here. And I'm going to moles of HCl. So even though I wrote it this way, be careful as to how you put it over here. So the 2 goes with the aluminum, and the 6 goes with the hydrochloric acid. And then again, you're going to run your numbers. Now, you can do it without doing any simplification if you would like. Just run it your calculator. Or if you would like, you could come in and simplify that and make that 3 to 1, which that makes it pretty easy to do the multiplication in your head. And therefore, my final answer would be 9.99 moles of HCl. Okay, so you're going to go ahead and finish the next 2. Again, you're going to set those up the same way. Remember to identify your given. Determine which way your mole ratio needs to be. Remember, it is always the moles of what you need over the moles of given. And again, you're going to go ahead and work on 2 and 3. And again, show all your work as I showed you above.